Hey guys, welcome to our project presentation. We are thrilled to introduce you to the collision simulator. To kick things off, let's delve into the developmental process that went behind in making this project possible. We began the planning stage on the 10th of February, wherein we collectively brainstormed various ideas. We developed version 1 on the 15th of March, in which we fixed the number of balls such that they would collide with each other and the velocity would be affected in the ideal simulation. We do this to demonstrate the law of conservation of energy. We then developed version 2 on 29th of March and added a new feature that allowed users to set up the size of the screen, numbers of balls going to collide, and their radiuses, minimum and maximum. Finally, we worked on version 3 on the 2nd of April, in which we added another new feature that would display a table on change of kinetic energy and mechanical energy for each ball's unique identity. Now, let's run the code. Now, setting all the default values, here's what the occurred collision looks like. Let's go through the details of the code. First, we set up the program and initialize the variables as can be seen through lines 6 up to 33. By using the number of balls as the example of the other variables, we set the default as 80, which means 18 balls of different sizes will appear on the screen. However, if the user wishes to enter another integer apart from 18, it has to be in the range of 1 to 100. Then, the number of balls will store that value for later process.
Alright, now let's introduce the concept of OOP, which stands for the Object-Oriented Programming. First, let's understand what an object is. The object we're going to be dealing with in this code is also recognized as instance. From this line onwards, you'll see that there's an instance called self, which is also the object we're going to focus on in the remaining program. From line 37 up to 46, it's just we set several parameters align with this one to initialize them. And then the update method, we just increment the board's x and y coordinate by its velocity, same as its kinetic energy. To draw is to set up the screen. And to check whether the collision occur, we can compare its radius. When there's an overlap, then that means the board's been collided. Based on the Newton's second law, which is also how we recognize later on with the conservation of energy. When after the boards being collided in the elastic, after the boards encounter with elastic collision, the speed, both of them supposed to remain the same. And then, as you see, it will be added up to there. And then to initialize, it's just to call the class. After that, we're gonna set up a screen, the storage bars in a string in a list, and then to randomize it and append those values back to the string. For here, it's just when the key down is when the user press the key, and here the key being pressed is supposed to be a space. So when the user click the screen and then press space, the screen will froze. After that, it will press it again, it will work again. And then to initialize the total kinetic energy at 0 and set the y position or at 10 to set the initialize the I, which later on we use by using the increment. It's also going to be 0 in the start. For here, you may wonder why they're using these weird symbols. So here it means that there will be the two significant for the velocity. However, for these, there's no f's, so that will be integer and it's not going to be a float. So now let's back onto the code. For the other problems we've encountered here are the OP were not fully applied. So if it's not applicable, check on Google to retry it. And then to freeze the screen, it's not working. Restart the library. And after that, there was a question because we did not set up the path for the Python, so it was not working if we ran this spider. However, once you set it up, it works perfectly. I mean, it also works when you just run as a main. And that's it. Thank you for watching this.